Hello. This is finding the derivative of a composite function, also known as the chain rule. I wish my pen worked, but we'll try another one. So at the top it says rewrite the function f of x equals 2x plus 3 as a function in polynomial form, then find f prime of x. We did this multiple times in the last unit. So when I multiply in polynomial form, it's going to be 2x plus 3 times 2x plus 3 times 2x plus 3, like so. So 4, I get 4x plus 12x, 4x squared, excuse me, plus 9. Then I multiply my 2x plus 3. That gives me 8x cubed plus 24x squared plus 18x. Distribute my 3, I get 12x squared plus 36x plus 27. Combining like terms, I get 8x cubed plus 36x squared plus 36 and 18 is, I don't know, 54x plus 27. And when I find the derivative of that, I get 24x squared minus 72x plus 54. So this may be an actual rule where the first problem we are going to save some time. The chain rule for composite functions. Okay, this is a composite function. This is something inside being squared as well. So we will call this, you remember composite functions from pre-cal, of f of x, f of g of x. Okay, that's a composite function. So I'm going to say if f of g of x, if big P of x equals f of g of x, then the derivative of p of x equals the derivative of the inside, g prime of x, times the derivative of the big function. The derivative of the inside times the derivative of the outside. So, you're probably very confused. A lot of people don't like the chain rule the first couple times they see it. Let's use the chain rule to find this first derivative. So I'm going to let the inside part be g of x, and then okay, so g prime of x equals 2, f prime of x equals 3x. Now, what did x equal to? 2x plus 3. So, it is going to be this times this. So, 2 times 3, I'm sorry, this is supposed to be squared, 2x plus 3 squared. Multiply out, you get 6 times 2x plus 3. And that's your final answer. Alright, so Before I move down to another example, let me show you another easy cubic function. Let's go 4x plus 6 to the fourth. Let's call this h of x. So therefore, h prime of x will equal to, I'll bring my 4 out front, this is the derivative of the outside, 4x plus 6, that stays the same, to the third, okay? I haven't messed with it. I didn't mess with the inside here. I just brought the 3 down and took it down. Now I'm going to take the derivative of the inside. 4x, the derivative of 4x is 4, so h prime of x will equal to 16. Oh, you can't distribute that. Oh, I'm sorry. 4 times 4. 16, 4x plus 6 cubed. Okay? So there's 2 examples to get you started on the chain rule. Now, of course, it's not always that easy. You've got to find the slope of the normal line of this one, sine squared theta. It doesn't look as if this is the chain rule, but it is. This is sine theta squared. Okay? So when I differentiate that, I'm going to have 2 sine theta to the first, and then I take the derivative of the inside, which is sine theta. So that's f of theta equals, so f prime of theta will equal to 2 sine theta to the first times the derivative of sine, which is cosine theta. Okay? Now, finding the slope of the normal line, so the slope of the tangent line is equal to f prime of 3 pi over 4. So 2 sine of 3 pi over 4 cosine 3 pi over 4. Okay? Now usually I don't do this in class, but since it's a video and you can always fast forward it, let's look at the unit circle to figure out what sine of 3 pi over 4. Okay? So this is 1 pi over 4, 2 pi over 4. This is 3 pi over 4. So my x and y is going to be square root of 2 over 2, square root of 2 over 2. Negative, negative, negative. So 2 times sine of 3 over 4 is positive square root of 2 over 2. Cosine is negative square root of 2 over 2. Alright, multiplying this out, those 2's cancel. Square root of 2 times the square root of 2 is 2. So I get negative 2 over 2, which is negative 1. Remember, this is the slope of my tangent. So the slope of my normal is going to be positive 1. So the negative reciprocal. Alright, so now I've got y minus equals 1. We don't have to put that. X minus 3 pi over 4. Then, how do I find y? I plug it back into the original. And we already found that sine 3 pi over 4 was square root of 2 over 2. How do you square a fraction? You square the top and square the bottom and simplify. So my equation of my line is y minus 1/2 equals m1 minus x minus 3 over 4. Okay, some examples to do. Alright, so 3. Bring your 3 down. Leave everything else alone. light kind of interferes with the, there we go, that's better. So I get 3x squared plus 2 squared times the derivative of what's inside, 6x. Just clean it up a little bit. We don't usually stress too much simplification. And there you have it. Next example. This is 2x plus 5 to the 1/2. Hopefully at this point in the semester you've gotten okay with rational exponents. Bring your 1/2 out front. 2x plus 5 to the negative 1/2. Derivative of what's inside, 2. Everything cancels. I'm left with 1 over square root of 2x plus 5. Right, the next one. I'm going to bring this 5 out front and leave it alone to the end. X squared plus 2x to the 1/3. Taking the derivative of the outside, I get 5/3 x squared plus 2x, negative 2/3. The derivative of the inside will be 2x plus 2. If you wanted to clean it up a little bit, that would be appropriate. Alright, moving along. This h of x is also equal to x plus 2 to the 2/3. Bring the 2/3 down. Subtract 1, or 3 over 3. Makes it a negative 1/3. Take the derivative of the inside, which is 1. And that's it. If you wanted to not leave that negative exponent, last example. Cosine squared of 3x. So this is kind of a double whammy. We've got the cosine and the 3x on the inside. So this is the first one. We're actually going to have to use this rule 3 times in this problem. 3. One for the squared cosine, one for the cosine in the middle, and then one for the 3x. So this is really cosine of 3x squared. So I write it like that. What's inside cosine? What's inside of that 3x? So start with the easiest part. Bring your 2 down front and multiply it by what's inside. And then take it to the first power. Now, take your derivative of cosine 3x. Well, your derivative of cosine 3x would be minus sine 3x, and then you also have this inside piece, which the derivative of 3x is also 3. So this is going to be negative sine 3x times 3. So I can multiply the negative 1, the 3, and the 2 together, and that's pretty much all I can do. So I have negative 6 cosine 3x sine 3x. It's a three-part problem. Same thing with the next one. It's also a three-part problem. I've got the squared, I've got the inside what's being squared, I got a sine, and inside the sine I've got 2x plus 1. So first things first, I'm going to rewrite it in a manner that looks like the chain rule to me, with something inside of something. Bring your 2 down front. Take your derivative of your sine. So sine, the derivative of sine, of course, is cosine. And the derivative of what's inside of that piece, which is just 2. Multiply out, I get 4 sine 2x plus 1 cosine 2x plus 1. So a lot going on in those two. Alright. So now you've got the big 3 rules of differentiation: the product, the quotient, and the chain rule. Now at this point you have to be saying, please, let's work a problem with all 3 pieces, or at least 2 of the 3 pieces. Well, no need to fear. Here we go. I have 5x times x plus 3, square root of x plus 3. So this is a product rule, and when I take the derivative of this part of the product, I will be using the chain rule. So the derivative of 5x, so the product rule is the derivative of the first part, which is 5x. So 5 times the second part, square root of x plus 3, plus. Alright, so the derivative of x plus 3. So the derivative of x plus 3, or square root of x plus 3, remember this is x plus 3 to the 1/2. So I'll bring my 1/2 out front. 1/2 x plus 3 to the negative 1/2. And then times the inside, which of course this time is 1, so that makes things nice. So I just place that in there. So I've got 5 square root of x plus 3 plus 5x times 1/2 x plus 3 to the negative 1/2. If you would like to clean it up, don't get caught up too much simplifying. And there you have it. The next one. So I've got a trig function with something inside which produces the chain rule, and then I've also got something inside which is a quotient rule. So we'll be multiplying all of that times our trig function. The derivative of sine is cosine. Don't mess with the inside yet. That's just the derivative of the outside. We have to multiply it times the derivative in the inside, which is a quotient rule. So it's the derivative of the top, 2, times the bottom, minus the derivative of the bottom, 1, times the top. All of that over. We can clean all this up just a little bit. Don't get caught up in too much detail of simplifying. Alright, so this will be 2x minus 2x as those will go. That's negative 3 minus 1 is negative 4. And there you have it. Do not get caught up simplifying too much. It's not necessary. Alright, winding this thing down. One more example. Here I've got a square root with something inside which produces my chain rule, and I've got a quotient. So the derivative of the top, if this is the top, then let's get used to this notation. It's long on the right. I don't like it, but I think you'll see it a good bit on an AP test. So that equals 1/2 2x plus 5 to the negative 1/2 times 2. So your 2's will cancel, and so it's 1 over square root of 2x plus 5. So going here with the quotient rule, the derivative of the top is all of that, 2x plus 5 times x minus 3 minus the derivative of the bottom, which is 1, 2x plus 5, all of that over x minus 3 squared. Could you simplify it? Yes. I don't know why you would want to, but that's all you can do. You could find a common denominator and get rid of some square roots and possibly get rid of it, but more chance of making an error. Okay. Graphical analysis. So given the graph of h of x, it's pictured to the right. It's not h prime. Make sure we're good on that. It's easy for me to change, as y'all saw in the last test, a whole problem just by changing this graph from being h to h prime. So we want to find the equation of the tangent line of the graph p of x square root of h of x when x is 4. So first of all, like we always do, let's figure out what p prime of x equals to. So that is equal to h of x to the 1/2 power. So that equals to 1/2 h of x to the negative 1/2 times the derivative of h of x. So I want to find p. Alright, so I'm looking for the tangent line of the graph of p of x. So I need to find my slope first. So my slope is p prime of negative 4. So 1/2 h of negative 4, negative 1/2 times h prime of negative 4. So h of negative 4 is right on our graph, 1, 2, 3, 4, 1, 2, 3, 4. So 1/2, 4 to the negative 1/2. So remember, this is the square root of 2 in the denominator, the square root of 4 in the denominator, which just happens to be 2. So far I've got 1/4 times. Now, h prime of negative 4 is this slope. This is the slope of h at negative 4. So what is it? It's down 1, 2 over 1, 2, 3. So it looks like it's negative 2/3. So let me count it up. 1, 2, 1, 2, 3. Hold on, I counted that wrong. It's 1, 2, 1, 2, 3, 4. So negative 2 over 4. So it's negative 1/2. So that will equal to negative 1 over 8. So this is the slope of my tangent line. Make sure we remember, we're looking for the tangent. So now I've got y minus equals negative 1/8 x minus 4 minus negative 4, which is x plus 4. I've got y minus here What is my y value at -4? Well, that's just where our original is at -4. We already found it. -4 is 4. And that's it. So that's a good graphical analysis of the chain rule. And then our favorites, our fun charts. So, last page of the chain rule. Given h of x equals f of g of x is increasing, is it increasing, decreasing, relative max or min when x equals 3? So x equals 3. Excuse me. We need to find out if h is positive or negative. So we're going to go or if it's 0 at x equals 3. So the first thing we need to do is find out what h prime of x equals to. Well, remember that equals the derivative of the big function times the derivative of the inside. So I need to know what g of x is, and g prime of x and f prime of x. So we're looking for h prime of 3 to determine if it's positive, negative, or 0. So f prime of g of 3 times g prime of 3. So g prime of 3 is 6. G of 3 is 4. Keeping it on, f prime of 4 is 8. Alright, because h prime of x is, this is my reason, this is important. This is important for an AP test. Because h prime of x is greater than 0, h of x is increasing at 3. Call it x equals 3. Alright, 2 more examples. So we want to know what the value of p prime of 1 is. Well, first of all, we need to find what p prime is. So it's 2 times, well, it's g prime of 2x, and then times the derivative of the inside, which is 2. Let me make sure I'm staying consistent with my wording. So I need to find out what p prime of 1 is, so I plug 1 in for all my x's. 2 times 1 is 2. G prime of 2 is -1. That equals 2. So p prime of 1 equals -2. And then the last one. If q of x equals the square root of f of x plus g of x, what is the value of q prime of 4? So I need to find out what q prime is. So q prime of x equals to f of x plus g of x, all raised to the 1/2. So bring 1/2 out front, f of x plus g of x, and then we multiply, that's to the -1/2. That's a 1. And then we multiply it by the derivative of the inside, which is f prime of x plus g prime of x. And I want to know what q prime of 4 is. So all my x's in there. 1/2 f of 4 plus g of 4 to the -1/2 times f prime of 4 plus g prime of 4. So f of 4 is 1. g of 4 is 7 times f prime of 4 is 8 plus g prime of 4 is -2. All of those are on our chart. So I got 1/2 square root of 8 times 6. So if you wanted to simplify it, that's 2 square roots of 2 in the bottom. So I get 3 over square root of 2. Alright, that's good enough. What does this say about q of x when x equals 4? Well, it's positive, so therefore, square root of 2. 3 square roots of 2 is greater than 0, therefore q of x is increasing. Okay, I hope this helped.